Welcome, .NET friends. It's time for another episode of the On.NET Live Show, where our mission is to empower you, the .NET community, to achieve more. I'm your host, Scott Addie, and I'm joined by co-hosts Maira Wenzel and Stephen Tobe. We are thrilled to have today's guest join the show, Adnan Rafiq. Adnan, could you briefly introduce yourself to the audience?
Hi, everybody. Well, my name is Adnan, and I have been working with .NET since like eternity. I think it's been almost 20 years now. I started back in 2003. On my website, it says 15 years. I don't know why I changed that, because I don't want to sound too old. Well, I am from Pakistan. I grew up in a small village and then moved to a big city. You see on the screen right here. That's Lahore. That's where I studied, and it is a great city, great nightlife, and that's where most of the friends still live, and I greatly miss it. I moved to Dubai. One day I worked in, one of the ticketing site there and in the government. It's a great place. It's a very, very fun place. Great weather. You don't need to wear jackets in the fall. That's for sure. It's pretty hot. It can get hot there, but still is fine. And from the past 7 to 8 years, I have been working in Boston, living with my wife and 3 beautiful kids. And the Boston is also a very happening place. The weather is very brutal, especially in winter. And I don't mind snowing, but um, when it's windy, I hate that. And that season is about to start. Um, on my technical journey, I started with VB6, developing desktop applications and all that, moved to classic ASP. And then one day, one of my manager told, okay, you got to do .NET framework stuff. So started there and slowly. And it's been almost 2 decades that now I am maintaining a legacy application here in Boston, which has very old technologies like ASP.NET Framework, WCF, um, and we are migrating some of our apps to .NET 6 to get all the benefits. We did actually migrate a couple of services in my team, and we are recently in the process of migrating um, a WCF service to WCF Core, and one team, in fact, in my company actually did migrate the whole thing. That was very bold because it's a production app, has a lot of users in there. So that I think we're going to talk about today, that how it went, what was the issue.
Yeah,
Yeah.
that sounds super interesting. So 2 decades of experience in the .NET space, and you've lived all over the world. So chances are you've seen some things out in the wild. Um, Today, you wanted to talk about kind of the diagnostics and perf aspect of the migration journey. Is that correct?
Yeah, that is correct. So the story goes like that. The team a couple of months back posted on a Slack channel that they are having some DevOps issues. I was like, what you guys are doing? And they said, we were migrating to .NET 6. And I wanted to migrate our application to .NET 6 because .NET framework is really getting old, and seeing all the perf posts and all the benefits and all the cross-platform things and the new ecosystem and the minimal API magic and all that, that makes your heart twitch a little bit. Okay, why I'm not doing that? On top of that, it's good for business too. More stability, better ecosystem. So I said, wow, because they are doing the whole thing, like whole application. So it's a very talented team, and they, did it very meticulously. Migrated all the, they use the migration assistant along the way. Um, have some Windows services. It has all sort of stuff. Had WCF, some of the services, and there are a lot of integrations um, with SOAP-based services, which are written in Java. But when you are in I guess, in an enterprise, you can't change everything. You have to just live with it. So then they started load testing it, and that's where the issue started happening. But still, bravely moved to production, and that's where one day the production just pops, and that's where the diagnostic. Uh, that's when we try to diagnose it, like what happened. Everything was working fine in .NET framework, and that's when the thread pool and all those things come into play, and you have to pick it up.
So Adnan, do you happen to know which version of .NET Framework you were migrating from?
So it's quite diverse. There are multiple teams who use .NET, but mostly I would say we are beyond 4.6.1. Some teams my team currently uses 4.71. For some reason, we were not able to hit 4.72 last time we did that. Um, because of all those assembly binding issues, nobody want to deal with that, right? I'm glad that .NET team has moved it to into the project settings and make it more smoother and nicer. And that whole assembly binding thing is a thing in the past. Uh, so it's quite diverse.
And so I'm curious on how your team decided to, like, you have all these projects that are done at like some different kinds of projects like WCF and ASP.NET Framework. Like, how did your team go about it to organize the migration in terms of what goes first and like what pieces and how did you task that? And so, like, can you talk a little bit about that?
Oh yeah, sure. That's actually a very good question, and it's actually one of the first thing the team discusses. Like, okay, we're gonna migrate. Okay, what benefits we're gonna get, and once we establish the value, okay, yeah, okay, let's move. But how do we wanna do that? There are a lot of users who depend upon us on daily basis. You don't want to break them. You don't want to break any feature, and since it's legacy. I don't want to say legacy since it's old stable systems. Like most of my team maintain the system which has been working for the last like 12 years and serving users without any major issues. I would say without any problems and user. So once you start migrate an application where user depends upon you and you don't want to have downtime, you have to carefully craft your migration journey. So one of the first step we did is, as a team, decided to feature flag it. Like we use Windows servers, virtual machines to host it on IaaS, partner framework. Yeah, it can only run on Windows. So what we did is we just simply got YARP in it, yet another proxy, uh, and put a simple feature flag in the app config and use the options monitor to see which one is working, and then keep the traffic to the old, and then if the endpoint is the new one is available, there is some if conditions over there. We just wanted to keep it really, really simple. Don't want to call anything external service to monitor the feature flag. So because it's really in the hard path, because some of our services are really I don't know, it's like you can get thousands of requests per minute. Um, it's pretty busy. The concurrent load can go up to like 4,000 users at any during busy times, but not all the time. So every application has that. So we feature flag it, and it's kind of a sidecar deployment. I think it worked fast. We have been running it for like now 6 to 8 months because we are very slow in migrating each controller. So that's the approach we took. But another team took the altogether different approach. They assessed it. They said, okay, if you want to migrate, let's migrate the whole thing. So I think both works well. If the whole team is on board and you are planning to do it in X number of months and you're ready for surprises and you are ready to deal with it. In other words, if you have a robust testing system before you get into production to build that confidence, I think that's also a way to go.
So Adnan, you mentioned feature flags. Were you using any kind of product to implement feature flags, or was this a custom feature flag implementation?
So actually, we have both. In the .NET framework, we have external product we use to feature flag other things. Like if you want to release backward compatible, if you don't not sure how this is going to play out. But for this one, for the migration one, we did we did not want it to call any external service on the in the middleware. We just want to keep it simple because this is IIS. You host another process, and then you change the port to 80 and you listen on the .NET Core with the ER proxy, and then you get the URL, and now you move the .NET framework instead of having the public front face, you move it to another port and close that port. So it's local. So it's kind of sidecar deployment. That sort of pattern, I think that's what people call it. But that's what we figured that's the easiest and simplest approach we can take. So we just change the URL. Okay, so if we have config values in the app settings, and we flip the feature flag, and then we need if this controller is migrated, then request goes through the .NET Core pipeline. Otherwise, forward it to the HTTP localhost, whatever port you have on it, and the YARP will take care of the sending the response back. It has some issues we experienced in that one, but that was not like showstopper, like options chat snapshot. It on us a 6 always shows up in our traces. So we use external service application monitoring system. It adds a couple of milliseconds sometime during really under high load, but otherwise it's okay. I think this is the simplest approach in migration if you want to migrate incrementally. Don't want to have full blown out feature. You don't need a feature flag, full blown out feature flag for that one per se.
Yeah,
it depends on your deployment.
Yeah, I think unless you're trying to take the big bang approach, something like feature flags is definitely the way to go, in my opinion. But I'm wondering, as you were using those feature flags, you probably learned a few things that you should continue to do, potentially things you shouldn't do in the future. Could you share any of those lessons learned with the audience with feature flags?
So the question is that, what feature flags bring to the table, if I understand correctly, are the underlying technology you have to migrate to get there?
Yeah, let's talk about what feature flags brought to the table for your team, and then maybe some lessons that you learned while using feature flags.
So we use feature flags for other purposes. That's one thing. When you're deploying a feature, let's say new feature, you build some new UI and on top of old UI, and now you want to test that how user respond to that. That's one use case. Or you implemented it, but you does not have the full confidence. Like, what if it blows out, right? You want a fail-safe scenario, especially when you have live users. And I work in education company, so we can't really afford if the students can't take their exam in the class. So you have to play really, really safe in that area. It's not. So I think every application is is like that. So that is that's where the feature flag shines. You can just flip the flag, and your old service is already stable. We have done that actually. We have actually done that 3 times now because we missed some of the tests, and our production was popping up. There was some, logical bugs. The reason for that is that once you migrate, there are other decisions underlying it. Like, as I said, it's been more than a decade old app. So we use DBML files. We use enterprise library for the data access. So those are no longer supported in .NET Core. We had to write it, I think now there are extensions in the EF code to execute SPs and all that. So we are very SP heavy application because of the nature of it. SP means stored procedures, SQL Server. So we had to write a generator to generate code based on that. But I think the lesson here is in the .NET ecosystem. I think when people, especially the data access technology, when people choose it, you can always pick up the shiny toy at the given time. But I would say that that's the one lesson we learned over the time since I'm working for like 8 years. Be really careful when you take any dependency. If you are going to maintain it for the long term, like we literally had to write thousands of lines of the code again because we use enterprise library. And though it was easy by generating, some of the SP calls on top of Dapper. So if you're using Entity Framework, or if you're using Dapper, or if you are using homegrown, take the dependency and maintain it. Or in other words, the lesson here is continuously upgrade. I think the .NET LTS system is great in a way that it kind of reminds you every 2 years, you got to update. So with the .NET framework mindset, it was totally different. It's still the sport is there, but that's the lesson. I think picking up your dependencies is should be thoughtful choice rather than on a hinge, I would say.
And did you use any of the migration tools that we offer, like the Upgrade Assistant, to do this migration?
Yes, we did.
And how far did that take you? Like, was it 50%, 80%? Like, do you have an idea?
So I tried that. It depends upon the application to application basis. One thing they really shine is that they can point out the incompatibilities. I have used both the Microsoft one and there is AWS one as well. They have a UI interface which can point out the dependencies which are not compatible, and you can browse a source from there. And the Microsoft one is CLI based. You can keep upgrading and you can see how it goes. So it goes. We have another application. We had made the mistake of using HTTP context beyond the controller boundaries because that's the way it was done in .NET Framework mostly. So whenever we will plan to migrate that one, that will be a very hard dependency to remove, especially if you have dependency on system.web. Those are not automatically fixable. You have to write a wrapper around that, if you want to control that, control the scope of that, because it can cause issues, right? At the end of the day, the way HTTP context works in .NET Core is, I guess, certainly different than .NET Framework.
Okay. And you mentioned that you migrated and then you start hitting production issues.
Yes, yeah.
Diagnostic story. And so like what did you use and how was that experience? So if you can tell us a little bit.
Yeah, sure. And let me bring up the
share your screen.
Okay. So I'm just trying to reproduce the issue here. It's just I wrote the minimal API here. The context here is that you migrated the application. Now it is integrated with the WCF service. It's not per se WCF. Written is your application is consuming something SOAP over basic HTTP. That's how you consume any SOAP service in .NET Core, right? You generate the proxy and you communicate with over it. So the other side doesn't really matter. That whatever it is written on, it's the protocol which you are using here. So I got little app here written in .NET Core WCF, which is very simple. I ping get data because I'm just trying to reproduce the issue. And then I have a couple of endpoints here. This is simple, minimal API, couple of endpoints, hello world, thread pool config. We're going to talk about that one in a little bit more detail once we see the issue. And then I have multiple variants of using the WCF client itself. That's where the issue happened, coupled with a few other things. And so rephrasing the context is that now that your production is kind of hanging, throwing 503s. It's not going anywhere. And in some instances, your process is crashing as well. So luckily, we had the team which my company had a robust load test around to throw any kind of load on an application in an isolated environment. So we started testing, reproducing the issue in the load test scenario. We were able to produce, and the application crashed. That's where I started looking into it. I was really interested because I had done something similar in the .NET framework application. So in .NET framework, when your application is like IO heavy, all you're doing is reading the data from the DB and pulling it back. You're not like, processing images or, processing videos per se, which spikes the CPU. So if your load is IO based, the normal thread pool configs in .NET framework is like how many cores you have. That's what the default config comes out with. So I had to adjust in the .NET framework as well, because if your load is always consistent, like if you are getting, let's say, 100 requests per minute, and that's your average, everything might just work out. But if you all of a sudden gets like thousands of requests in the given time frame, then the thread pool config might not work for you. It might slow down, or it might even, eventually hang, given that how that scenario plays out. So I just give the overview here, and I think that's pretty simple. And I have this Docker Compose. Let me just run it. And
does your team have like any favorite load testing tools that you like to use?
yes, it's we use JMeter, but I'm glad you asked that. And we are trying to actually move out of JMeter because of the certain issues. But it's broadly JMeter and Gatling. But there are some new tools out there we are still evaluating, that maybe the K6. But JMeter is the obvious choice, because it just makes it's UI based, and there are a lot of skills available out there to test it. So the WCF is running here, and the .NET Core minimal API is also is fine. So the issue we were getting in production is that the requests were just hanging, like no logs, whatever. Like what's going on, we didn't know. So when you talk about, okay, you got good logs, when people talk about mostly about observability, you have configured the CL log, you got all the structured logs in there, and you have the application monitoring system, performance monitoring vendors, third-party vendors, whatever it may be for you. It can point out certain scenarios, but it won't give you the underlying reasons the why it is happening. They are very helpful, that you don't have to look it up by yourself for everything. It can give you clues. So we are noticing that logs are not really coming out. It's just that request is just hanging and then finally crashing out. That was the symptom. And based on the experience, my first thought was that what is your throughput? What is application request rate is coming in. So that was quite heavy. It was in thousands. So, and based on, then you have to look into your infrastructure, like how many, you obviously, application is running behind load balancer. You calculate roughly, if you're getting 1,000 requests, you have 4 servers or 8 servers, how many, in the round robin fashion, how many each one is getting at any given time. And from there, you kind of know that how many requests is landing on that any particular machine on any given second based on the load. Like we use terminology of 1x, 2x, and 3x based on different profiles of the application. So thread pool was the first thought, that okay, the thread pool is, we could have adjusted just the thread pool and try to test it again, but that would be really throwing the dart in dark and see if it hits. Sometimes you got to do that, but I want to see if I can reproduce with the WCF inside the in an isolation. Because when you're having a load test or any production load, there are so many endpoints and there are so many other things happening. And if you are not totally isolated load, like not running Kubernetes or Windows containers, so you might host multiple processes under IaaS. So profiling that will just make it more difficult. So sometimes you gotta bring that small scenario and try to reproduce it. If you can do that, that will be good. So I tried that. I just wrote this client similar to this one and see what is our thread pool config looks like based on the experiences in the .NET framework. Another thing which was missed in the migration was that it is old app. Nobody remembered it, that we changed the thread pool configs at the global level. In .NET framework, you can change in the process config, auto configuration in this. I'm forgetting the name of the global web.config, and it will be a machine-wide change. And when you're migrating an application to .NET 6, you're not going to look at all those global configurations. It is you're just migrating the current code you are having. Am I making sense? Just checking.
Yeah, this makes a lot of sense. So if just to kind of reiterate what I'm seeing here, you're using a minimal API in .NET 6, I believe. You've created this thread pool config endpoint to kind of isolate the endpoints here to figure out what's going on. And you're taking a look at the thread pool statistics. We had a related question come up in the chat that I wanted to ask. I'll pop it up on the screen. Our friend David Pine from the content engineering team asks, was it difficult to troubleshoot these issues after migrating? Were there any docs that helped? And then how can we as Microsoft improve the experience?
Yes, thanks for the question, David. Yes, the docs did help, in fact. While preparing this tutorial, I followed one of the docs on the Microsoft side, which has the diagnostic section on the Microsoft docs. I think that's pretty neat and to the point. That's what I'm going to just use. So I have, let me just show you. I think it's very, some people might even find it. Let me actually go to the Docker and open it, because the terminal I want to use is let me bring up the Docker here. Okay, I will just .NET. So you can see something like, so this is the process I'm running here, so you can monitor it. So this will bring up, payload like this one. So, and since we are simply trying to see what our thread pool looks like, so this .NET counters has a lot of counters. You can pick and choose the one you want. But in this, for the demo purposes, we are looking at three things, which is thread pool queue length, and thread pool count, and thread pool work items. And here I'm gonna just open the thread pool config where I'm running. Well, so we can go here. So this is the thread pool config here. So we have the minimum worker threads and the minimum IO threads. I'm fetching out. It seems like the max is 1,000, and the minimum worker thread is set at 500, and the IO thread is 1, which is odd. In fact, it should be 1,000. The .NET Core defaults 1,000. I don't know why this. The code looks fine. So this is what we can fix. So what that thread pool means here. So thread pool means here that when you are sending a request, like I did send on the browser here, it creates a worker thread. Worker thread is the thread which does your work. And as soon as if you're using async await or the state machine behind the scene, it will hand over to IO thread, and when that IO is done, it will bring it back to the worker thread. Now, when you are migrating an application, if you notice here, I am not using async await here, because that's how .NET Framework legacy WCF clients. If you have OLAP, or even not all, if you're using sync over async, it was working like that. So this is a sync call. This is not an async call. So if I'm going to call this one, so we discovered that there were a lot of calls like that with an external service. So now our option was that, do we want to convert all the way async, which is the recommended approach. But that is not super easy. There are plugins available to convert the paths with the analyzers and all that. But you have to. The con is that how you're gonna test your application stability, right? If you have full coverage, do you have all the integration tests? Do you do manual QA? So I bet every application is different. I haven't seen any application with 100% coverage where you can just say, oh, everything just works. So that is the con. If you cannot do that, you just reliably test the whole path, you might not want to take the risk and convert everything. Now, here, what will happen is that the worker thread, when I send the request here, the worker thread will be blocked until the IO is done, and then it's gonna resume on the context on the worker thread. So if your config looks like that, you have only so I have this runtime config here. So I guess I'm configuring here 500. That's why it was saying 500. You can override the default configuration of the thread pool. If you don't have that, let's say if I'm going to delete that, and then we're going to check.
And so while we wait for that to build, I want to make we invited Steven today, and if you don't know him, he is famous for his perf blog posts on the .NET blog. He just last month, I think we had the .NET 8 improvements, and so that's there's a book for every release, and it's awesome. And so you should always check it out, because if you need you need reasons for your team to migrate to the latest version of .NET, that post alone can give you a lot of reasons, because just by migrating your application from one version to the other gives you a lot of benefits. But Steven, do you have any tidbits in terms of when working with thread pools or anything that you've seen here, like, are there any recommendations for teams in terms of perf and what they should be watching out for?
I mean, I can try. I mean, the throughput issue that's shown of basically, blocking every request waiting for I/O, synchronously blocking every request waiting for I/O, is one of, if not the most common sources of throughput regressions or temporary deadlocks, where basically all the threads in the thread pool end up getting blocked, and they all end up effectively waiting for themselves, because in order for another thread to become available to complete that request, something has to end, but something's not going to end until it frees up, and you have kind of the typical deadlock cycle. So then you end up waiting for the thread pool to realize that it's not making any forward progress, and for it to inject additional threads. And it's very hesitant to do so, because too many threads is also bad. And so it's fairly conservative in how frequently its starvation mechanism will inject additional threads, on the order of half a second or a second per additional thread. And so if you look at your task manager or your stats, your logging or your metrics or whatever on how many threads are in use, you'll in this situation, you'll often see like a little stair step pattern, where once you're basically deadlocked, every second another thread's going to get introduced, until eventually something gives, and then everything clears out, and then you're kind of back. So the typical solution that people employ, if they're not going to quote unquote do the right thing, make everything async, and I realize there are reasons that people don't, is they do end up bumping up that minimum thread pool count. And what that does is it just changes the thread pool's level of conservativeness, basically. So up until that minimum level, the thread pool will say, if it has a work item that comes in and there isn't a thread immediately available to service it, it'll inject another thread, rather than waiting for one of its other mechanisms to say that doing so is valuable. And so if you set it to 500, that means if you have fewer than 500 threads currently processing something in the pool, and a work item arrives, it will inject another thread to process that immediately. The downside to this is you end up with 500 threads very quickly. And if they're doing anything other than just blocking blocking in the kernel, waiting for something to happen, now those threads start competing with each other. So if you've got an 8-core system, and you have 500 threads that are all runnable all at the same time, you're also going to see significant regressions in more compute-bound workloads, because all the operating system is going to be swapping those 500 threads like crazy on those 8 cores, and they're all going to be competing, and they're all going to be killing each other's caches, and the whole thing also falls over. So the right answer really is make everything go async. But I get that is a process. We did add an additional mechanism in .NET 7, which it sounds like you're not quite on yet, to help with this. I'm curious, in your repro, I saw you had, get data or something, the synchronous thing, and then there was a get data result at the end. I'm assuming that was doing a task.wait or a task.getAwaiter.get results or something.
It's just a property on the data contract. I just named it.
Given that the thing was doing an await, I assume somewhere in that get data there is a blocking operation somewhere.
Yeah. So this is something which we the .NET Core WCF proxy generates. So when you consume a service, it's just that. So it is. So this one is doing so eventually doing the wait on the
task,
on the handle itself.
Oh, on the yeah, okay. So in .NET 7 we added another mechanism that is specific to blocking on tasks, since that's the most common form we see of sync over async. So basically, if you block on a task, you do task.wait or task of t.result or task.getAwaiter.getResult or anything that's effectively blocking on that task. That signals to the thread pool to make it more aggressive. And so it will more aggressively inject additional threads to try and compensate. Um,
Yes. So,
these
yeah, that is great explanation. I think the great way to think about is in three zones, right? The green zone and the yellow zone and the red zone, both thread pool. The symptoms we used a bit, based on the learnings from the docs and the blogs, is that uh, you have to analyze your workload. If your workload is IO based, then you can take the risk to bump the threads up, especially the min threads, because the max thread is already in .NET Core is set at really highest. So what it does is that you set the min threads, let's say 100, and that's your green zone. Until you reach the 100, everything is fine.
Right.
If your throughput is below 100 on that particular machine, you are in the green zone. As soon as you reach the min thread, and beyond that, it's your yellow zone. But it depends upon multiple things.
Well, and that's the key. What you just said is the workload is, whatever value you choose, you're betting that your the number of requests per second is going to be within under some threshold, because the moment it crosses over that threshold, you haven't actually solved the problem. You've just mitigated it for the smaller volume. If you set the number of threads at 500, but you are super successful, and all of a sudden, you roll out some ad and everyone's hitting your service, and now you're getting, 10,000 requests per second or 20,000 requests per second. All of a sudden, you can still end up in a situation where all 500 of those minimum threads are blocked, and now you're back in the same predicament.
Yeah, we just had another production issue recently where everything is working. It's a .NET framework. So we are using min threads to compensate there, because we understand our workload is IO based on the services concerned. But what happens is that if an external service which you are talking to is somehow slow, or the network is just slow, so even though your request rate is still below your minimum, let's say 100, but now what is happening that your requests are taking longer than usual. Now, again, you will run into that situation, and that will be really bad. It will be actually worse than before now, because
you made it more likely that all 500 of your threads are going to be blocked at the same time. And the moment that happens, then the only way one of them makes forward progress is by the thread pool injecting another thread to compensate. That's why the answer ends up being async.
There was another question from David as well. I think you were mentioning some thread blocking issues, Stephen. That so is there an analyzer that could be used to help discover and address those issues?
Certainly, some of them. If you have direct calls in your application to things that are known to block, an analyzer can certainly detect it. But if you just have a method called get data, and that's some other library that an analyzer can't see into, it has no way of knowing whether that get data call is doing IO and waiting for some service halfway around the world to get back to you at some point, or whether it's retrieving a value stored in a cached field and it's going to complete instantly. So an analyzer can tell you about some things, but it can't tell you about them all. There are other approaches that people have employed. Ben Adams had tried something where he had a little tool where basically it would flag anytime it saw you blocking waiting on certain kinds of things. So it wasn't a static analyzer, it was a runtime, dynamic thing, but it would inform you. Profiles, if you take traces, you can see this stuff happening in traces. It often reveals itself pretty quickly in any kind of load test, because what often happens in a load test is you'll start the load test and nothing will happen for like 10 seconds because you have to wait for the thread pool to inject enough threads to deal with the load. Whereas in a load test, if everything was asynchronous, it should start responding immediately. But there's no perfect answer.
So we didn't face the issue initially as well. Like we were fine within our less than 1x load, and even in production we were fine for a couple of weeks. It only happened once we crossed that threshold, and then everything started falling down. So I'm just sending a request here, and I'm gonna just do repo it. I want to mention another thing we encountered, which is really
And you also use, I know you're in a Mac right now, but you also use some of the Visual Studio diagnostic tools, right, to analyze
yes,
the perf issues that you did.
as Stefan already explained, the thread pool mechanism. The only way forward is, if you want to get rid of the problem altogether, is go async await. You can take the incremental path, which we took is we migrated the hot path to async after we discovered the thread pool queue was the only integration. If you're having a thread pool problem, is you run the .NET monitor on your process, and this value should be greater than 0. Depending upon your throughput, what kind of load you are throwing on that particular host, the more load it is, the more threads gonna queue if you're facing a thread starvation issue. So we did migrate async to await on the hot path, and that brought us very stable on our load. And then another issue which in the migration we missed was that by default .NET used the JSON.NET, the new JSON package. So we had one model which was hierarchical, like parent-child relation. So you have parent-child, you keep going. So we ignored it with the JSON.NET attribute class, and later on we discovered that we moved to Newton sorted JSON, and we kind of just missed that. So thread pool issue long now. That one was like doing some something evil, I would say. It was calling the DB inside it, so it would go through DB, fetch the the child, and then traverse it, and so then go again. So it was sort of n+1 problem introduced by the when it's trying to serialize the object. So it will traverse, and that introduced some garbage collection on that part. And when the garbage collection was taken out, so that was popping out ADO.NET connection timeout issues along with thread pool, and that's where I want to mention the debug diag. I have used it in multiple situations successfully. I know there are other tools like WinDebug people love. When debug is really simple tool. You take a dump from your host machine, you provide it to the data file, and it has built in like 6 different diagnostics in it. You check, hangs, you check memory problems, and then you start analyzing it. At the end of it, it will give you a report, which is in MHT format. It's hard to open, but if you struggle enough to open it, what it does is that, as you can see, these numbers here are if you're using .NET trace tool, you have to traverse yourself among all threads to run different commands, which relates to which one. But the debug diag, what it does is it groups similar threads automatically. It sort of gives you a report that 12% of threads are waiting for this one, and that one has triggered the GC. And then you can look at those group of threads and see what those thread stack traces are doing. And once you saw that, that's how we discovered the JSON serialization issue, which was triggering the GC eventually, and we fixed that. And similarly, you can see here, since I was making the sync call here, so it will tell you that, okay, X number 30% of the threads are waiting for the wait one, for the signal to wait to finish the IO and then come back. So here is the WCF does is that it blocks the thread differently. They have their own syntax implemented to support the sync calls, and they wait on the handle itself inside the deep inside the code, rather than just waiting on the task itself. I guess to save some allocations, are they must have very good reasons, better than I do. So you can see that stack trace. So it ran all the diagnostic, and it'll come up and show you that these are wrong. So quickly you will be able to view in the UI itself what is going on. And from further there, you can take clues, and then you can start looking into the dot trace itself by using tools like perf, which shows you another angle of your application with a dump, that what percentage was spent in the GC and how many garbage collections are happening. It has a nice chart as well, and then you have the tree view as well. So we use combination of perf view, debug diag. Although debug diag is really old, but it's one of my favorite, that it is so easy to use, and it runs most of the basic, I would say, the common scenarios automatically for you, and it just compiles the report, and you can make sense really easily. So that really helped.
Just ask one question. I want to make sure I heard something correctly. You said that you were migrating from JSON.NET to system text JSON, or did you say the other way?
The other way. So we initially, when we migrated, by default it uses text JSON, right?
Yeah.
So we ignored that, but later on, once we realized that it's going to be more work for us due to compatibility issues with the client side and all that, we don't want to deal with that. So we ended up going back to the Newtonsoft, and they both have different JSON ignore attribute classes. So in the process, we missed that, we are ignoring this. We were sure like, oh, we are ignoring it, but eventually, there is not really a good way to test that out.
It'd be interesting to, not right now, but subsequently, if you wanted to open an issue in .NET Runtime or something, it'd be interesting to understand the driving factor behind, you mentioned compatibility, but the driving factor behind switching back from system text JSON to JSON.NET. That's generally the opposite direction that we recommend.
Yeah, I understand that. The driving factor here is to get over the migration quickly. Teams don't want to spend months just to land in production or land in a stable environment, right? That's the driver here. When you have a legacy app which is working, the product or the management won't approve. I would say, I don't want to say my manager is really awesome. They won't approve the migration if you tell them it takes 6 months. I mean, for 6 months, you don't want to hold up, right? 3 team members or 2 team members just doing the migration. There are so many other things which happen in product lifecycle which you got to take care of. So the driving factor is not that the technology is bad. Driving factor is the prioritization, that which one you want to do first. So you have to make the pros and cons. Okay, it's fine to use the Newtonsoft. It worked for a decade. Why wouldn't it work now? Yeah, there will be less performance, but I believe the driving factor varies between teams. Our driving factor is performance, yes, but it's more about moving beyond Windows VMs and moving to cloud eventually, and getting all the benefits. And the ecosystem is also moving really quickly beyond .NET Framework.
So it's a temporary staging thing.
Yes.
Rather than okay, got it.
Yes, I just should have said that.
Before we wrap up, is there anything else you would like to share on that? We're getting up on time here.
Yeah, I wasn't really up to the mark to the demo. Sorry if people were expecting really, like, we just got into the thread pool thing and it just keeps keeps going on and on. I hope it's okay.
It's okay.
That makes me feel useful. So yeah, it's great.
While we have Stephen on the stream, I wanted to ask a question that viewers may be wondering. For customers like Adnan who run into issues like this, if you were personally debugging this, what would be the first thing that you take a look at?
I think what I saw was the first thing that he did, which was get a dump. Because, one of two things. Either if you already have good telemetry, as he pointed out, you can see something going wrong very quickly with something like the thread pool numbers, right? You can see that your thread count has steadily increased to beyond a reasonable value. And if you have good telemetry, you probably also have alerts in place that are going to fire when you start hitting some upper bounds that you consider reasonable. Or you can look at your data around thread pool queue length, and again, you probably have some kind of alerts in place to say, hey, like this queue length is getting out of hand. This isn't just a temporary spike. Something's wrong. Someone's pager's going off. But once you know that there's a problem, getting a dump is the fastest way to seeing where the problem is, because once you have a dump, you can just look and see what, if something isn't making forward progress, 9 times out of 10, it's because threads are stuck. And so you want to see what they're stuck on. And then there are various tools, including, for example, parallel stacks in Visual Studio, or the equivalent commands with the .NET dump tool and SOS that will quickly show you kind of, if you have 1,000 threads, like you're not going to go clicking through 1,000 different threads, but they'll quickly consolidate them based on their call stacks. And so you can see, all right, out of my 1,000 threads, 992 of them are stuck on this one path. And that points to, exactly where you need to go and spend your time. And I should point out that this isn't just an issue with synchronous blocking. There are situations where you can hit this with async as well. The cause is different, but the symptoms can end up being the same. It's usually a much larger scale too. It's not I have 500 threads blocked. It's I have 500,000 requests that haven't made forward progress, because they're all 499,273 of them are all in the same sort of asynchronous call stack, leading to something that has gone wrong. And those tools, whether parallel stacks or the dump async command and SOS, those will point to exactly what, where you should be looking. So invariably, that's the first thing I do. If someone gives me a dump, if someone says I have a problem, I say take a dump, and then they give me the dump, and I open it up in one of those tools, and I see what I see. And 95% of the time, whatever stat I previously gave, it's that. And if it's not that, then you start digging deeper. And then it starts getting off into the weeds of, unusual situations that require more investigation. But that's almost always the cause.
All right. Thank you for that. Unfortunately, we're out of time for today's show, so I wanted to wrap things up here. Thank you to Stephen for joining us today and sharing his expertise. Thank you to Adnan for joining and representing a real-world customer's experience. That was awesome to see. I'd like to thank all of our viewers for tuning in today. As a reminder, you can check out other pre-recorded streams like the one you saw today over at dot.net/live. If you tune in next week, we'll be joined by our very own Katie Savage, who will talk about a .NET modernization journey with customer Nop Commerce. You get to see a cool little interview taking place. So I hope to see you all next week. Thanks again. See you, everyone.
All right.